we saw something called as a ETL process. What is ETL process? It's nothing but extracting your data, transforming your data, and loading your data. You have data in the n number of sources. You just extract that data using tool. Once you extract that data, you transform there itself. Once you do transform, finally you load that into any of the data warehouse or data lake, any of the target location we are going to load that. Okay, this is what we used. For extracting, you can use n number of tools. There are n number of tools available in the market. That is, you can use inside AWS. If you want to use, you can use Glue, you can use Matillion, you can use Airflow, you can use ADF, we can use Informatica IRCS, a lot of tools. Okay, these tools are available where you can extract. For transformation, you can make use of any UI based transformations, or you can write your Python code, you can write your Scala code, you can make use of SQL also for the transformation, and then you can load that into a warehouse. Either it might be Snowflake, it might be Redshift, it might be BigQuery, any of the warehouse we can load. Okay, but what's the disadvantage of this? Okay, the disadvantage is scaling. Okay, as you see, the most of the ETL breaks in middle. Okay, it's inefficient. As if your data keep on increasing, volume keep on increasing, you have to scale your ETL tool also. And traditional ETL tools have their own limitations, and they can't scale beyond that. Okay, and increase in the labor needs. Why it's an increase in labor needs is a lot of maintenance is required, debugging is required, customization is required, and engineers have to manage the code, understand the workflow, and if they are using any UI based tools, then it is very hard to debug, and limitations are more because you can't do variety of transformation using UI tools. Okay, and then workflow reliability. Okay, you have written a lot of custom tools, you have written a lot of scripts, everything you have written, but you have to manage that pipeline, you have to manage that workflow. If there is any break in that particular workflow, it's very difficult. And more on top of that, your transformations are buried inside your pipeline. It's very hard to debug and audit. Okay, you want to audit what kind of things are happening, what kind of transformations are happening, where it is breaking, everything. It's very hard. The main thing is lack of version control. The the connection to Git is not available in most of the tools. Testing is not available. Now you are doing the transformations, but you don't know whether the transformations you are doing is validating your requirements. Okay, in every project, there will be a certain requirements that need to be met for the data, but that things come into the picture when you load the data into the last layer and we have a QA team. Another team comes into the picture, so increase in the labor, and they comes and they see whether the data you have loaded is proper or not. And if there are any bugs, they'll raise the bugs. Again, you have to go back and you have to start from the scratch and do the transformation and fix the bug. So a lot of work is required, and poor lineage tracking. What is the meaning lineage tracking is? You have a source, you did one transformation, you have a table T1, you have a table T2, you did transformation, you're joining these two, and you're creating one table 3. And based on this table 3, you're doing one more transformation, table 4. You're creating this n number of transformation, n number of tables. But if anything goes wrong here, to track back from where this particular data is coming, that particular lineage is lacking in most of the ETL tools. You have to do that manually, and difficulty with collaboration. Okay, most of the ETL tool don't have one collaborated workflow where you can work with a team, and it will be individual. Most of the things will be individual, and we have to work again, and we have to establish an external Git connection. Come with that, establish the Git connection, and then collaboratively work. Okay, I would not say it's completely not available, because any tool, if there is no collaborative workflow or is not available, then that's not a best tool. It will be there, but a lot of back-end work you have to do. And moreover, there is no CI/CD. What do you mean by CI/CD? Is you have developed your data in the dev environment. You have to move that to next environment, let's say QA. This is not an automated process. You have to come, you have to have a DevOps team. Again, you have to have a DevOps team. And this DevOps team need to set up a pipeline in the backend where it brings data from, it moves data from, or it moves code from one environment to another. These are some of the disadvantages. Okay, if you don't have any doubts, please don't be on mute. We can discuss more on that. Okay. These are some of the disadvantages we have in the traditional ETL tools. Okay, Krishna, any doubts? These are the limitations which have in the traditional ETL. For that, there comes a ETL tools. Okay, what these ETL tools are doing? It says just extract all your data and load into one data warehouse. Okay, now you no need to worry about transformations. Whatever the data you're coming, make use of any of the tools. Okay, it can be your Fivetron, it can be Matillion, it can be ADF, any of the tools you make use. Just lift that data and dump that data into data warehouse, and then I'll come into the picture. Okay, now what used to happen in ETL? You're extracting, you're transforming, and you're loading. Okay, and then if this particular data is again needed in some of the other application, again you have to extract from here, then load this. Okay, you have to do the reverse engineering. Okay, a multiple layer comes into the picture. Whereas in ELT, what used to happen, we just extract the data, we load that into any of the data warehouse. It can be your Snowflake, BigQuery, Redshift, Databricks, any of the things. Okay, we can load that data, and once that data is there in that lakehouse or data warehouse, directly go write a simple code. If you want to write in a code, you go with a SQL. You want to write in a Python, you go with a Python. You want to make use of Spark distribution, make use of PySpark. Okay, we can make use of all these things and then transform, and you no need to move out of that warehouse only. Once you transform, load that in that warehouse only. So again, you no need to worry, and debugging part, everything is much easy because everything is there in one single place. Okay, so now where DBT comes into the picture is you are having all these challenges. What I said, that you can't, you are doing transformations. Okay, you need to be make sure that it should be a simpler format. So DBT comes into the picture where it makes a we just make use of SQL code along with Jinja. I'll explain what is Jinja. Okay, we make this of code, write a simple low code transformations, sorry, and do transformation, and which very easy to debug, review, and audit. Git integration is well integrated with your DBT. You no need to worry. Any changes you do, once you do changes, push to Git just with a click of button. Inbuilt testing. Now you have done all the transformations, you have done everything. Now you can write a test cases directly inside DBT, and that test cases will validate whether the transformations, whatever you have done, is valid or not. Automated lineage. As I said, automated. You no need to worry about the lineage. You are connecting T1 to T2. It will create one lineage. T2 to T3, it will create a lineage automatically by itself. No need to worry. Analyst friendly. You can write SQL. SQL is the first preference language which we use in DBT. But even nowadays, Python is supported and CI/CD is integrated inside your DBT. You no need to worry. Just with a click of deploy, you just say deploy. It will deploy from one environment to another environment. Here, DevOps is eliminated. Here, QA is eliminated. Here, high-level data engineers are also eliminated. So using DBT, what comes into the picture is data analytical engineer. That is nothing but you don't need to be a data engineer, you don't need to be QA, you don't need DevOps. Only you need to have a basic knowledge on SQL and bit knowledge of Snowflake or any data warehouse tool. Your DBT is good to go.